I was working with it the other night on these places.
I will be late tomorrow. I want to go get prosthetics. I don't know, but it's
Sublime, Rob, and DJ.
I'm not DJ. Train of thought is coming. It's Matt's birthday, so we all have to go.
His birthday weekend.
Yeah, I think it's like the day after. Last year it was her birthday on Crosstalk, so we got them.
Alright, so first of all, some of you may have noticed that I posted the next homework problem set on Blackboard. If you didn't notice, that's fine too. You'll have plenty of time. This time you have until March 11th or something thereabouts to do the homework. So should be plenty of time, just don't leave it until the last moment. This time you have 10 attempts to do the homework, just to make sure you guys are not really constrained by time or attempts and thinking about the problems. But you have to start early. If you leave your homework until the day it is due, then no number of attempts is going to help you. Well, some number will, but you know. So I suggest that you take a look at it early, think about the problems. If you have any questions, take some time on them. If you want to discuss it with your friends, that's fine. Just don't give away, the farm to anybody. The idea is for you guys to try to apply what you learn and think about it, as opposed to just giving things away. Okay. Any questions about that? Also, I meant to ask you at some point, but I didn't yet, so I'll ask now. Does anyone have any questions from the first homework problem set that you'd like to discuss? Yes?
Can you do number 6? I think it was.
That doesn't tell. Number 6 doesn't tell me much. Which one? Okay.
I put together, I found it.
Only 3? You had 5.
Oh, something about that.
But no, I'll pull it up and we can take a look. There it goes. Okay. All right, so right here on the course content, you see homework 2. That's your next one. All right, there on the bottom. Once it warms up, you'll see it at least. All right, so let's go check out our homework 1. Problem number 6. Okay. Now let's zoom in a little bit so you guys can see. How about that? Okay. All right. So what do we have here? You have 12 coin tosses. You lose 150 and you lose 100. That's the probability of winning with a net loss. Okay. So the first step in the problem is to figure out what is the number of wins that will produce a net loss for you out of 12, given these payouts, right? So what is the maximum number of wins you can have out of 12 and still have a net loss? You guys did this problem, so you could, Well, why don't we give it a try, right? If we have 5 wins, what happens? 5 times we win $150, right? So we get 5 times 150. And then the other 7 times, we lose 100, right? So what do we get? So we get 750 minus 100 is plus 50. So we still win. 4
Yeah.
8, right? Yeah. So at 5 we're still winning. So we could have 4 and 8. And then we have a net loss of 4 to 8. Right? So it becomes 600 versus 800 until we have a loss. So in order to have a net loss from this game, we can win 4 times, or 3 times, or 2 times, or 1 time, or 0 times, right? And only in those cases will we have a net loss after this game, right? Everybody with me? Okay. So, of course, so this is a relatively small number. You could actually just try some winning losses and see what happens. Generally, you can set up an equation that tells you what your net winnings are, given some number of wins, right? So in general, you can say x times 150, where x is the number of wins that you have, right? Plus 12 minus x times minus 100. Right? And we want that to be, well, equal or less than, so you want it to like equality, equal to 0, right? And you'll find the number of wins that will produce exactly 0 outcomes. So anything less than that, you're going to lose, right? And so it will come out to be something like 4.5, something like that. So say, okay, 4 wins or less will give me 1. Right? Okay, so now our question is, what is the probability of ending up with a net loss? So in order to figure out that probability, we need to figure out the probability of having 0 wins, the probability of having 1 win, 2 wins, 3 wins, and 4 wins. Right? So what is the probability of having exactly 0 wins out of 12 tosses? You don't have to give me like an actual decimal number, just give me a fraction. Right. 1/2 to the 12th, right? Because the probability of having a loss in the first toss is 1/2, and the second toss also 1/2, etc., right? So we have 12 independent events, right? So the probability of all of them happening is the product over the probability, right? So 1/2 to it, so 1/2 to the 12 is 1/4096, right? So something on the order of 0.45 or something like that, right? Add another couple. All right? Okay. So that's good. We have that licked. Now we can say, what is the probability of ending up with only one win? All right, in order to answer that question, we need to know how many sequences of wins and losses will produce exactly one win out of 12 possible. What do you guys say? I was just asking about the number of sequences. Right? So how many sequences, right? So there'll be 12 of them, right? Because you can have one win in the first position, or you can have one win in the second position, or you can have one win in the third position, and so on and so forth, right? So you have 12 unique sequences of outcomes that produce only one win, right? Now what is the probability of each of those sequences occurring? Right? It's 1 half to the 12th, right? Regardless of what the sequence is, the probability of that happening is 1 half times 1 half times 1 half, 12 times. Right? So the total probability of getting, the total probability of getting one win is we can land on 12 of these sequences. Right? So the probability of landing on any one of them is going to be 12 times 1 half to the 12. Right? Make sense? That's with me? Alright. So then we say, okay, what is the probability of ending up with 2 wins out of 12? So our first question is, how many sequences of wins and losses produce exactly 2 wins out of 12? Almost. Off by a factor of 2. All right, there you go. Because remember when we were looking at positioning our wind, and we say there are 12 possibilities for the first and 11 possibilities for the second, so we 12 times 11, we're producing duplicates, right? Because a win in the first position and a win in the second counts as a different thing as a win in the second and a win in the first, even though they're the same, right? So we have to take out the duplicate permutations of the same combination of wins. Right? So we need 12 times 11 divided by 2, which is 6 times 11, which is 66. Right? So we'll have 66 of these sequences, and each one of these has a probability of 1 half to the 12. Right? So the probability of getting 2 wins is 66 times 1 half to the 12. Right? Any questions? You running that? Okay. Then we say, okay, what is the probability for 3 wins out of 12? And so we need to know how many of these sequences will produce exactly 3 wins. All right, there you go, right? Because there are 3 factorial ways to rearrange 3 winning positions, right? So we'll do 12 times 11 times 10, and then factor out all the duplicates, and there are 6 duplicates for each sequence, right? Okay, so 12 times 11 times 10 divided by 6 is 6 times 11 times 10, right? So do 660. Yeah? Okay? And we'll have 660 of these that produce 3 wins, and each one of these sequences has a probability of 1 half to the 12. Right? Okay.
Is it
Yeah?
220?
What? So 6 times 11 times 10. Oh, 12 divided by 6 is 2. That is correct. Yeah, I said it was 660, and you're like, yeah. Was thanks. Alright, so we have 12 times 11 times 10 divided by 6, right? So we have 12 is 6 is 2, which is 2 times 11 times 10, which is, right? In, my mental math, I said 2 was 6, right? This is on. Yes.
Why did it say?
So 6 here is a 3 factorial, right? It's the number of ways we can commute the positions of where the wind is there, right? So in other words, we can have, have a wind in position 1, position 2, and position 3. It's the same thing as having a wind in position 2 and position 1 and position 2, right? Because when we count 12 times 11 times 10, we're looking at all these permutations of our organization that we want to factor because they're different reasons. We don't care which order they use. Right? Any other questions? We're okay so far? Okay, and finally, the last possibility is that you have 4 winds out of 12. So how many ways can we produce 4 winds out of 12? All right, there we go. All right. So whatever we have is 12, 11, 29, divided by 4 factorial, which is 2, 4, right? So we might as well take 1. Right? So what do we have? 4 divided by 4 is 3, and 3 divided by 3 is 1. So 12 and 4 are out, right? We cancel that. So 10 divided by 2 is 5, so it's 11 times 9 times 5. Right? What's that? So there we go. 495. And each one of these has a probability of 2 1 half of the world. Right? So now we have just enumerated all the possibilities that can occur that will produce a net loss. Right? So the total probability of producing a net loss is if this or that or that or that or that happens. Right? So that will be the sum of all these probabilities. Right? So, and I mean, another thing you can say is, okay, so there are a total of 4,096 possible outcomes from throwing the coin 12 times, right? Individual possible outcomes, right? So how many of these possible outcomes will produce a net loss? So you say, okay, we have 1 plus 12 plus 56 plus 52 plus 295. Whatever that to be, right? So this is the count of these outcomes that will produce a net loss. I'm not sure how many is that. Something in the order of 200.
794. 794.
All right, 794, I'll buy that. All right, so 794 out of 4,096 outcomes will produce a net loss. And these are all happening randomly, because each outcome is as likely as all the others. Right? So what is the probability of getting a net loss? 794 out of 4,096. Right? It's like saying, what is the probability of landing on 1 out of a 6-sided die? Well, each side happens with equal probability, so it's 1 out of 6. In this case, it's like having a 4,096-sided die that we're throwing. And we're saying, what is the probability of landing on any one of these 794 faces? Right? And so that would just be 794 out of the total number of faces there are. Right? Any questions? Do we buy that? Yep. And so, this will, 794 out of 4,096 do something on the order of 20%, right?
No.
That's on the order of 20%. Okay? Makes sense? All right. Any other questions that you guys want to talk about from the first homework? If not, I'll assume you guys know how to do all that stuff. Okay? All right. So that is that. Now, let us let us move along to our traditional logic puzzles. So who would like to propose a solution to our last puzzle? I'm sure you all have been thinking hard about for the past few days. Yes. And why is that?
Because in basis, when you agree with me, if you wasn't it, you would step in it. And if you know it, you know it.
So, I mean, as it happens, it isn't the case that they're both not, right? But let's think more carefully about these, this inclusive or proposition that we're being controlled, right? So we can say, okay, what if A is an A, right? Now, in that case, the first part of this proposition would be true, I have an A. And because this is an inclusive OR, that means that as long as at least one of the parts of the proposition is true, the whole thing evaluates for true, right? So therefore, he cannot be an A because he would be saying a statement which has a true value of true, right? Regardless of what the second half is, as long as one of them is true, the whole thing is going to be true, right? So therefore, he has to be an I. Now, if he's an I, then, and he says that, then the whole statement has to evaluate to true. But we know that the first part is false. Because I'm an A would be false when he's an I. So in order for the whole OR statement to evaluate to true, the other half has to be true, right? Because if the other half is also false, the whole statement would be false, and again we would have a logical contradiction. Right? So as a result, that means that B has to be an I in order for the first statement to evaluate to true when A is an I. Right? Everybody with us? Making sense? All right, so this is one of the sort of wonderful little gems of formal logic that you can say something true or anything else, and the whole statement is evaluated to true. All right, so I could say 2 plus 2 is 4, or I'm a giant insecure alien coming here to consume human beings, and it would be true, because 2 plus 2 is 4. Right? Right, because it's an OR statement. 2 plus 2 is true. Doesn't matter what the other one is. It's the whole thing evaluates true. Right? So if you want to make sure that everything you say is always true, you could just append some truism and OR to it. Right? Did you eat my cookies? No. Right? So, you should just say, yeah, I always tell the truth. Well, if all my statements evaluate the truth, you can just always append some, something with an OR to make sure that it's true, right? Did you rob that bank? No. Or I have 2 legs. It's true. Okay.
Somehow I don't think
Oh, I mean, that is not to say that the others are not going to start to suspect something, but at least you are always saying the truth, right? And if they don't like it, you can be like, I want my lawyer, or 2 times 2 is 4. Any questions? Okay. All right, then let's go on to the next puzzle. The next main thing is a really fertile ground for logic puzzles. I figured I'll throw in another one. continue along. Okay, we'll discuss it next time. Next thing I wanted to do is finish off some stuff with our return simulations that we didn't finish last time. So let me whip out my R here. Okay. So last time when we were looking at stuff, first of all, let's just review. Number one, we were simulating returns of the market portfolio, looking using the normal distribution of the historical mean of about 10%, right? And historical standard deviation of 50%. Now, because we know that, again, if we invest in risky assets out there in the marketplace, we're not going to get a fixed rate of return like we did in the simplistic return. Items are going to change. And depending on what's going on in the future, predicting the future is really hard, right? So we don't know what's going to happen. Maybe things are going to be relatively good and returns are going to be great, and only money handle risk. Or maybe things are going to be sucky and we have, a couple of great depressions on our hand or whatever, and so we're not going to make much money at all, right? So we saw that it is possible that we will end up with really a large amount of money, pretty nice, or really not so large amount of money. Now, it's still better than having nothing, right? And you can really never guarantee exactly what will happen. But, even the not so large amounts of money they're still pretty decent, right? And then once we threw in adjustment for inflation, as far as the amounts of money that we're putting in every year, right, things started looking even better, right? Because we're putting in more money over time, so we have sort of a larger base from which we're growing, right? Now, one thing that we didn't do correctly last time is, we messed something up, right? I was kind of thinking back over it after class, and I was like, we did something wrong. Fortune customers. No, just kidding. We did something wrong. Let me just review again what we did, right? So first thing is we generated a sequence of returns from the normal distribution, right? So we said, okay, I'm going to generate sequence of return. Normal distribution 50. Well, let me for now let's just do 10, so we don't have to look at so many numbers at once, right? But we'll go back to 50 in a bit, right? With a mean of 0.1 and a standard deviation of 0.15, right? So we generate some random returns out of this return distribution. Then we said, okay, what we need to do is, we're going to accumulate this growth over time. So every period, we need to multiply by 1 plus the rate, right? So we said, all right, what we're going to do is, we're going to take 1 plus this rate, and then we're going to take a cumulative product of all of these things, right? And these are not reflecting the previous values, because every time you call R norm, it generates new random values, right? But you can see that generally over time, right? For the first one, we have some of those, and gradually we're increasing our cumulative growth over these 10 periods. It appears that this sample is actually doing pretty good because we managed to almost quintuple our investment over 10 years. Yes, lucky draw. It's not necessarily going to happen depending on what the rates are. So these are our cumulative products, right? And then we said, okay, in order to figure out how much our $5,000 investments are going to grow to, we're just going to take that and multiply it by 5,000, right? And that will give us sort of the returns, the final amounts of money that we get at the end from each of the $5,000 that we invest, right? But then we said, wait a second. We are going to increase the amount of money that we invest every year because, say, the IRA contribution units are going to go up, and generally the price levels are going up, and the dollars are not as valuable, so chances are we'll have more dollars to be throwing around, right? So let us produce also a sequence of contribution amounts, right? So let me just generate the cumulative products, and I'll store this into variables, so we can refer to that, right? So there is our x, right? And then I'm going to generate a sequence of contribution amounts, and I'll assume that we have a 3% inflation, and I'll raise it to the, well, so in this case, not 0 to 9, right? And so that will give us how much we're going to be putting in every year, right? And so then we will just multiply the two vectors together, and we'll have the result of our investment. Now, as it happens, you can observe right now, right, that if we multiply these two vectors together, what we're saying is that our 5,000 here will grow for 1 period, and our 5150 will grow for 2 periods, and our 53 whatever will grow for 3 periods. Which is actually the inverse of what is going to happen, right? Because our first 5,000 is going to grow, has 10 years to grow, not 1 year, all right? Our second 5,000 has 9 years to grow, not, or second 5150, not 2 years. So what we need to do is we actually need to reverse the order of one of these vectors in order to produce the correct result, all right? Because otherwise what we're saying is that our last contribution is going to have the most periods to grow, which is, of course, completely incorrect for this guy. I mean, it's correct, it's incorrect. Right? So, as a result, I mean, and this is what we did, right? We just multiplied these two together, we actually produced an incorrect result, and what we have seen, in fact, is that we had much greater variation in outcomes. Right? You remember we had like, 50 million, and then we had like 1 million, right? And the thing is, the reason is because of the cumulative variation, the final product, right, the final result of investment over all these years varies a lot more than a single year's investment, right? A single year's investment stays, it's about 10% plus or minus, 30% or so, right? That's our normal distribution. But a 50-year investment with all of these things varying randomly can vary from, once you multiply 1 plus r 50 times, you get a lot more variation. You can go from like 10 to like 200, right? There's a lot more variation. And so now we're taking all this extra variation, and we're putting it on the largest investment that goes to the smallest one, right? So actually, if we invert the vectors, we should actually experience a reduced variance in our total cumulative investment account value at the end. And then what we saw when we did it wrong, and we didn't invert the vectors, right? You guys get what I'm saying? Like why what we did was incorrect, right? You guys get what I'm saying? Why what we did resulted in higher variation in final outcome? Okay, all right. So now let's get back to 50 periods, right? And see what happens. Okay. So first of all, right, we're going to cumulative product, blah, blah, blah. Alright, so first of all, we're going to have 50 of them again, right? So we're generating 50 returns, and we're accumulating them by, 1 plus the rate for the varying number of periods, right? And second of all, we're going to take our 5,000, and 1.03, and we're going to raise it to the power, not 0 to 49, but 49 to 0, right? So we're basically inverting the order of the vectors right there, right? So 49 to 0. All right, so now this, instead of having our, right, so this is 0 to 9, we start with 0, 1, 2, etc. Doing it the other way, this generates a sequence going from top to bottom as opposed to from bottom to top, so our vector is inverted, right? Okay? And so this will produce a vector of length 50, giving us the value of each one of our investments. But now we actually have the correct number of periods for each one to grow, as opposed to having them incorrect. Right? So if we do that, right, this is this is the value of our investments, of each one of our investments, right? Okay. So just as a quick quiz, and on which end of this vector do we get the very last investment that we made? That's going to be the first one, right? Even it is more than 5,000, right? Because it grew by 3% by inflation, so we ended up at the end putting in $23,000, right? Right? Yes, that means that $23,000 in 50 years, assuming inflation is 3%, is going to be the same thing as 5,000 today. And in fact, if you look at historical inflation since over the past few decades, that's approximately what happened. The dollar today is worth about what 5 pennies would have been worth 50 years ago. It's actually even worse. Because we had a period of relatively high inflation in the 70s and part of the 80s, so it wasn't 3%, it was 10 to 15%. So it really sped up the depreciation of the dollar. Hopefully that's not going to happen, but anything can happen. There is no. There was a famous quote. Somebody said, "Making predictions is hard, especially if they're about the future." So we can never tell what's going to happen. Okay, so this is like one possible sequence of outcomes, right? And we can say, could generate another one, and now we can plot them again, right? So plot. Get a nice plot of the values of each one of our investments, right? This would be the value of the last one that we put in. This is the value of the first one. Not doing the value there, no? $100,000, Okay, so now we can say, all right, now I'm interested to know what is the distribution of the total value of my investment in 50 years? Like, what is, right? So what can possibly happen? Now we know what can possibly happen with the individual returns every year, right? But given our assumptions of what the distribution of returns is and what the inflation rate is going to be, what is the distribution of the total value of our retirement account at the end, right? We know that it's going to have some distribution. Some values are going to be relatively likely if things, no particularly unlikely things happen. Some values are going to be relatively unlikely, right? So it's going to be, again, some kind of normalish, bell curve-ish looking distribution, right? But it's possible that we'll end up with like really shitty outcome, and it's possible that we'll end up with a really, really good outcome. Neither of those would be really likely. The likely thing would happen somewhere in the middle. So how about using R, it is relatively easy to just say, let's just do this 10,000 times and see what are the outcomes looking like, right? We can then make like a histogram and see where most of the probability mass is, right? The histogram is like a poor-man probability distribution, right? Because we see like how many outcomes were in this range, how many in this range. So the more outcomes there are, the more likely that if we have a random outcome, it will be somewhere in a range where a lot of outcomes happen, right? So let's do this, right? So first of all, instead of plotting, we're going to just sum them to get the value, right? To get the value of our portfolio, right? So I run one simulation and say, check it out, we just made $5 million, right? I run another one. So check it out, we just made $6.3 million. So I can do this many, many times, and I'll get a I'll get a feel for where I'm most likely to end up, right? Statistically speaking. So let's do this, right? So let's create an empty vector of results. Empty vector of results, and then we're going to run a simple for loop that's going to do this 10,000 times. Right? Well, you can choose any number, but given the computer is going to do things for us for free and magically, you just choose 10,000 for this number, right? Why not? We can choose 100,000 if we wanted to, and then our runtime would increase from 0.2 seconds to like 2 seconds, and like who cares, right? So we can really play with large sample sizes when we're generating pseudorandom data, right? It's really easy. So we're going to run a for loop 10,000 times, right? And what we're going to say is we're going to append we're append a generated result. Right? This is going to be one of these. Right? Run of this. We're going to append that result to our vector of results 10,000 times. So we'll end up with a vector of 10,000 draws from this simulation. Right? Everybody with me? Okay. So we're going to say we're going to append to the result vector this thing. Right? And let's see if we don't get any. Okay, there is RR. Length of R, 10,000. Right? So now we have 10,000 samples from how much money we have in our portfolio simulation. Then I want to know what are these samples looking like. Well, one thing we could do is just look at the summary of results. What is the minimum? What is the maximum? What is the mean? What is the first quartile? What is the third quartile? Right? Something like that. Just simple statistical summary of our sample. So let's see. Summary of R. Okay, there we go. So the minimum possible outcome that we got was about $500,000. Kind of really shady over 50 years. Right? But notice it's the minimum out of 10,000, so the probability of producing 550,000 or so is about 1 out of 10,000, right? So that's a 1/100% chance that we'll end up with something as little as 550,000, right? On the upper end, our maximum was 107 million. Pretty awesome, right? But again, the probability of getting that much is something on the order of 1/100%, because we have to be all the way at the tail of our distribution. All right, so the mean here is about 8.9, about 9 million, right? The median is about 6.5 million. So this is approximately where we expect to end up after 50 years, right? Now let's see what this, if you look at the quartiles, right? So first quartile is 3.9 million, about 4. Third quartile, about 11 million. So it means that 75% of our observations, right, were within 3.9 million and 11 million, right? So that's basically where the most likely outcome is going to be, somewhere within those quartiles, right? And actually by 75%, I mean 50%, right? Because 25% are below the first quartile, and 25% are above the third quartile. So in the middle, we have 50%, right? Or 2 times. I should really get in the habit of appending that. So I can say, hey, I was right. I didn't know that. Okay. So, let's just see how these things are looking like as a histogram. All right, so you can see that this is a very skewed distribution, right? We can produce really large outcomes, right? But on the lower end, we're basically, we're never going to get anything less than 0, right? Really unlikely. I mean, actually hasn't happened. So, I mean, that's encouraging. Like, it's possible that we could get something really close to zero. It's like the market has minus 50% returns every year, right? Would basically be approaching zero. It's a good thing that it doesn't really happen. But still, it's a very skewed distribution. You can see that now, the scale is not particularly energizing here, right? So 2E07 is $20 million, right? So basically, very likely to be between $0 and $10 million, fairly likely to be between $10 and $20 million, and then to kind of tail it off from there. All right, so using these simulation methods, you can get an idea of what kind of risks we're looking at, right? Given what we can expect from the historical distribution of returns. It's good to know what to expect, right? If you're just saying I'm putting in $5,000, you don't really have a feeling for what that $5,000 is going to do for you, right? $5,000, whatever. It seems like a decent chunk of change, but it's nothing to write home about, right? But once we figure out what we can expect to happen over the next 50 years, assuming no cataclysmic events happen, right? You can get an idea that you're actually not doing too badly if you can manage to maintain your regular contributions to your investments, right? And so this is what you might get out of your IRA, assuming you make your contribution to IRA every year. Obviously, this is not going to be your only remaining wealth at the end, right? You'll have other assets, you'll have other investments, hopefully, right? But if everything doesn't starts circling the drain and you get a really, really bad investment outcome over 50 years, even just that should give you a pretty good base of assets by the time your 50 years are up. All right? Okay, so any questions? Any thoughts? Any comments? Any stories? All right. So that's basically all there to kind of give you an idea of how these things are working, what kind of outcomes you can expect, what is the meaning of exponential compound growth and what it produces as a result. I hope you kind of get, you understand how the math works, or at least you get better because it's in the homework. But in addition, I hope you have sort of a bit more of an intuitive feeling of what's actually going down. Right? Okay. So we're done with that. Now let's talk about some more day-to-day practical things about cash management. This is related to your reading from chapter 4 of Kitman. So I hope you read it. Very useful. So one of the questions I might ask you is, what is FDIC insurance? Anybody know what that is? Yeah?
The government will insure your money. After that, until you have a
Right, so that's exactly it. Back in the old days, none of us really remember them. During the Great Depression and the late 20s, early 30s, 1929, 1930, there was a lot of investor uncertainty, and people were not really sure what was going to happen. So a lot of people sort of rushed to the bank and wanted to withdraw their money. Right? Now, let's talk about how a banking institution operates. Right? When you put your deposit, into a checking or savings account in the bank, what happens to it? Where does it go? Right, exactly. The bank invested by loaning it out to people at a higher interest rate than they actually need, right? And because how the bank makes money. You can make money by taking the deposit and just sticking it in the wall and sitting there, right? Then you wouldn't be able to pay your interest. That's why you get these funds to get interest. Alright, so the bank isn't just sitting on that cash. So they're taking a bunch of people's deposits, and they're taking that money and they're investing it at a higher rate of interest than they're paying you. Right? And you make a difference on the spread. Now what this means, of course, is that if the bank takes in, say, $1 billion of deposits, out of that $1 billion, it actually has on hand maybe 10% of it, if you're lucky. Right? The other is just cash. You loaned out to business moves, invested in, depending on the type of financial institution, there are regulations and what exactly they can do with it. But most of it you can think, loaned out in mortgages, loaned out in business loans, basically they don't have it, right? So imagine here we are, we have a bank, let's say, $100 million. And if the bank has a relatively high reserve ratio, they might have $10 million worth of that those funds actually available, right? And the other $90 million, right? The $90 million is gone, and then it's still there. So, if everything is staying there going as normal, nothing unusual is happening, sometimes somebody will come in and want some money, and sometimes somebody will come in and deposit money, and so the $10 million is plenty of cushion to support sort of the daily needs for cash for the financial, right? But you can see that if, say, half of the people decide to come in and say, I want my money, the bank is not going to be able to give them their money because they only have 10 million, right? The other is out in loans. They loan it out to businesses, they loan it out to mortgages, they loan it out in personal consumer loans. If they say, I want my money, and they don't have it, they can go to the guy who bought the house with the mortgage and say, give me the money, right? Because the mortgage doesn't have the sort of call feature that the lender can say, give me my money now, right? And when the loans do not have the feature, so they do not have it. So what happens is that the bank says, no money, we failed, right? And so a lot of that happened around the Great Depression time because people were saying, well, these banks made a bunch of loans and maybe they're not going to get that money back, so I'm just going to go and take my money out of the bank, just in case, right? And then the next guy is saying, well, me too. And the next guy is saying, me three, right? And so now you have a bunch of people coming to these banks to get their money back, and all these banks say we don't have it, and so there was a bunch of financial institution failures. And I mean, it's not an irrational thing to do, right? If you're seeing some shit going down, and you know that, if you think you can be first in line to get some cash, you can be pretty safe, right? Because the first $10 million worth of guys can get their money. So everybody is basically running as fast as they can to the nearest bank once they realize that other people are starting to run to the nearest bank, right? Because they want to be in that 10 million to get their money. But obviously, not everybody can be in that 10 million, right? And so that was a kind of a rough and rowdy time back then. And so at that point, it was decided that it would be a good idea for the government to insure deposits so that people don't have to worry about banks failing if too many people withdraw, right? Because the reason that there was this cascade effect of everybody running to get their money is because there was no insurance on deposits. If the bank fails, they get no money. And so everybody wanted to be in that first batch and try to get the cash. But if everybody knows that no matter what happens, they're going to get their money back, now they don't have even an incentive to run to the bank and withdraw, right? So this insurance sort of prevents this incentive for a bank run, where everybody runs to the bank to get the money, right? So even though the bank still doesn't have all the money, right, and everybody knows that the bank doesn't have all the money if everybody requests it, nobody has an incentive to run and request it, right? Because they know it's safe anyway, so what's the point? I might as well let it sit. And as a result, then things can keep coming along without any problem. right? So that is the idea of FDIC insurance, right? So it insures the money that you deposit in the institution. So if the bank goes bankrupt or fails for other reason, the government is going to make sure that you get your money back. So you don't have to worry about it, right? So this sort of introduces a lot of stability in the financial system because now there are not these large waves of people being afraid of what's going on and withdrawing money from the bank, right? Make sense? Okay. So now, FDIC insurance has, over time, they've been raising it gradually. Like back when we first started, the maximum level of insurance was something like $5,000, right? And over time, they've raised it many times, and like up until a couple of years ago, it was $100,000, and then they raised it to $250,000. So now it is $250,000. Now, what this means is that if you have less than $250,000 in the bank, then you're golden. Everything is cool. No matter what happens, you're covered, right? But if you happen to have $500,000 in the bank in your one account, and the bank explodes and goes bankrupt, then you only get up to $250,000 back, right? The rest you can lose. So I mean, there are ways, and there's several ways and tricks to maximize your FDIC insurance. The obvious one is to put your money in different banks. Because it's $250,000 per financial institution. Right? So if you have $10 million, well, first of all, you shouldn't be keeping it all in the bank. Because you know what happens. If you trade them, you're really but let's say maybe you have $100 million, and of that, $10 million you keep in the bank, right? Or something, yeah, we all want to do that. But if you want to protect, if you want to make sure that you don't lose any money due to the banks when they're failing, right? You can just put your money in a bunch of different banks. Each one of those will be insured up to $250,000. Now the other thing is that again, like if you're married, you can have like $250,000 in your name, $250,000 in your spouse's name, and then you can have another $250,000 on an account, which is a trust account from you to your spouse, and then another one from your spouse to you. So you really can get up to like $1 million in FDIC insurance. But again, really, generally the idea is you don't really want to keep all that money just sitting in the bank and losing purchasing power for no good reason, right? $250,000 kind of ought to be plenty, especially given that you can hold a sort of trust account tricks as well. But really, we can have multiple bank accounts. So there's nothing wrong with that. The thing to watch out for is sometimes, and sort of on a transient basis, some people might have a lot more money in their bank account. Like when you sell your house, right? The guy who buys it from you basically eventually send to your bank the purchase price of the house, right? If you would have, sell a $500,000 house, you would have $500,000 in your bank account, right? And now, as it happens, during the housing crisis, a lot of financial institutions failed, a lot of the smaller ones mostly. Some people lost money when they failed because, if you just sold your house and you happen to have had like, $300,000 or $500,000 in your bank account, and the bank failed, well, at the time insurance was $100,000, not $50,000. And so you could have lost whatever extra you had there, right? You were not planning to keep it there forever, but it was just, there for a month or whatever, but you got it coming in, and some people lost money. That's not really acceptable, right? So, most of the time it's not something to worry about, but it's something to keep in mind if you have a transient surge of cash coming into your account, but try to make sure there is not a financial crisis. Right. Any questions about that? Okay. There are a bunch of products that banks would generally offer you in order to entice you to put cash in the bank. Right? Because remember, every deposit is a source of profit to the bank, so they can take that deposit and they're paying you crap percent interest, and then they're taking that and rolling it and charging crap load percent. Right? There's a big difference between crap percent and crap load percent, right? One is bad and one is good. I guess if you're a lender. Now, a checking account is a very useful product, right? You can keep track of your cash. You don't have to keep a bunch of cash in your pocket or in your mattress or whatever, where it could get stolen. Because if somebody comes in, robs you and takes your cash, it's gone pretty much, right? There's nothing you're gonna do. But if you have your cash in the bank, number one, it's much harder to rob a bank, right? Number two, again, it is FDIC insured, so even if somebody comes in and it just happens to just clean out the bank, right, you're still fine, right? So it's nice, right? You don't have to worry about securing a large, dense stash of value, right? You can just put it with someone who is professionally responsible for it, and it's also convenient. Like you can write checks. You can use ATMs and get money out of ATMs whenever you need it. There are benefits, and sometimes you get even some interest out of it, which is not so bad, right? Even though it's not really enough to write home about. So it's not a bad idea to have a checking account, right? It's it's kind of harder to deal with if you don't have a bank account. I mean, again, sometimes when you get once you start getting different bills coming in, like utilities, internet, whatever, if you want to pay those bills and you don't have a bank account, you have to buy money orders and mail them or whatever it is, right? And it's just like a giant pain. Have a bank account, you just go to the website, do online bill pay, and say, send this guy $50, and it's done, right? It goes a long way towards allowing you to optimize your life and spend less effort maintaining whatever it is you're doing, right? But the thing to watch out for is that, again, it is the goal of the firm, the goal of the bank, to make money. And so, a lot of times, banks make money not just on the interest differential, but they're also trying to make money on all sorts of fees everywhere you look. Right? So sometimes, you might go to an ATM and an ATM will charge you $3 in withdrawal fees, right? Or something like that. Or sometimes a bank account will have a monthly maintenance fee of $10, unless you keep some large amount of money there, right? And there are all sorts of at every chance they get, they're going to say, hey, can I slap a fee? Right? And so of course, it is in your interest to avoid those fees, because these things you can add up pretty fast, right? If you have a $10 monthly maintenance fee, you're just throwing out $120 a year. Now, $120 is it's not a world-shattering amount, but you can do some other stuff with $120, right? I'm sure you can think of better things to do than to give it away to the bank for free, right? If you're looking around for a checking account offering, one thing you want to watch out for is what are the fees, right? What are the different minimums? What are the interest rates? Not so much these days. Nobody pays anything worth speaking of, right? So how many of you have a bank checking account? Okay. How many of you know if you pay any monthly maintenance fees on the checking account? Okay, that's good. All right. So a lot of times it's they have special offerings for students. They're like, hey, no fees, no minimum, whatever. But once you stop being a student, they're like, huh, now so watch out. They try to throw some fees into it. Not all banks are the same. If you look at, say, Wells Fargo, they have an $8 monthly maintenance fee on their checking account, unless you keep $1,500 in there, right? Whereas if you look at, say, TD Bank, they don't have a monthly maintenance fee if you keep like $100 there. Like everybody can keep $100 in a checking account, right? So that's probably a lot better, right? Just watch it when you're setting these things up. Just watch out that you don't get a bum deal and end up paying some stupid fees that you don't need to be paying, right? Now another thing you can think about is if you constantly need to like deposit cash into your bank all the time. I would say like you work, you have like a waiter, you get tips, you got cash, and you deposit cash. And then probably you want to have a bank account with actual physical presence where you are. You just go to the bank branch and put some cash, put it in, right? But if you don't get a bunch of cash receipts over time, it might make sense to open a bank account in an online bank that doesn't have to spend all this money on building new branches. Right? So if you get, for example, like if you have a Wells Fargo savings account, they pay you right now 0.05% interest, which is so close to zero you need like a magnifying glass to see that it's not zero, right? It's the same thing with like TD Bank, like you have a savings account at TD Bank, like 0.0 something percent. But if you have a savings account with an online bank, you can get 0.75 to 0.9%. Again, this is, it's not like awesome, it's still less than inflation. And, your checking and saving account is always going to be less than inflation. But, 0.9% is approximately 18 times more than 0.05%, right? It's something to think about, right? If you don't need sort of physical access to the bank branch on a regular basis, and generally, like you go, even with a physical bank, most of the time, for me at least, like I just go to the website and do my stuff. I don't get a bunch of cash receipts. Unfortunately, I never got into like starting drugs business, so like no cash receipts, right? I just get like direct deposit from the university of my salary, like that's my income, so I don't have to worry about it. So I just have accounts at online banks, and I don't have to think about it. Now the other great thing is some banks give you rebates for ATM fees. Right? So normally, if you have like a bank account, you go to an ATM which doesn't belong to your bank, you will get charged some number of dollars in fees, right? Which may range from like 1 to as much as maybe like 6. So it's some kind of ATM in a popular location where they can get away with it, right? Now some banks give you ATM fee rebate. It doesn't matter where you withdraw your money, up to X dollars per month will rebate any ATM fee you withdraw. You can just go to any ATM, withdraw your money, and not even think about it, not even worry about it. Alright? That's pretty awesome, right? Because especially if you tend to like withdraw cash relatively often, right? And then you're like, hey, I could be saving like an extra $10 a month on all the ATM, right? Again, if you always withdraw cash from dual bank to it doesn't really matter. So it kind of depends on what your setup is, right? How things are working out for you. But for me, I can go to an ATM, take some cash, and not worry about it because my bank will rebate any ATM that I take. I'm a big fan of that feature, right? And then again, I only go to get cash at an ATM maybe like once every couple months, so it doesn't really make much difference to me. But still, it's nice not to have to think about it. Yes.
Doesn't it feel weird having like only online banking? Like there's no place to go to track down money physically.
They have their head office, right? And so it's hypothetically, like if you wanted, you could drop by their head office, and they have offices, right? Obviously, you don't want to open an account in an online bank without checking out that it's like a real bank.
Yeah,
that's true, right? I'm not saying you should go and just do it anywhere. Like you can check it out. I mean, you can look where like FDIC has a list of like all the banks that are actually insured with FDIC. Like they wouldn't FDIC insure some website that isn't an actual bank, all right? So you can actually check to make sure that it's an actual real-life financial institution, all right? And that's a good point, right? You don't want to just go Google for something and be like, oh, Bank of Bob, that looks pretty awesome, right? And it's just like some random guy's website. Yeah, you don't want to do that. Like, obviously you want to do your due diligence before you do that, right? But you know, I've been doing exclusively online banking since like 2000, and I haven't had any problems with it. So on the occasion that I get some I get like a check that I need to deposit, I actually have prepaid envelopes. Like they send me like business class postage paid envelope. I just stuff, sign the check, stick it in an envelope, send it to them, and like a couple of days later, it's in my account. So I mean, I don't have to think about it. Now, I mean, that's not to say that you all should do that, right? It depends, as I said, on what kind of transaction volume, what kind of transactions you have. But for me, it works. Just saying. Yeah? Any other questions?
Okay. Very good.
Oh, okay. Yeah, there we go. So hypothetically, you can also deposit cash at an ATM. I don't know if you've all ever done it, but they have envelope. You can deposit cash at an ATM, and so you could do that. But I've never deposited. I've never done that myself. Yes.
What happens if it gets lost in the mail?
Well, then you request a copy, like request a check copy from whoever gave it to you. Never happened to me though. Mail is pretty reliable, but again, if it gets lost, right, and then some random guy cannot just deposit it to himself because it's made out to you. So the worst thing that can happen is that it's lost, and you say, "Hey, can you give me another copy?" Right? So that's basically not really something to worry about. All right, so again, if you are really thin and you can't afford to wait a couple of business days for the check to make it to your bank, then again, maybe you might prefer to have a physical branch where you just take it in and say, "Here's the check," and like it'll be in your bank account. So we'll talk some more about this stuff next time on Tuesday. And then we'll go on to talk about Chapter 5, which is housing and vehicle financing decisions. And we'll go from there. Okay? All right.